Okay, hello once again. Okay, I'm Gibbs Mollel, presenting the case study of the Great Ruhr River Subbasin from the Rufigi Basin. And the project title goes by Unlocking the Resilience Benefits through Unlocking Integrated Hydrology Knowledge in the Rufigi Basin. And here is our case study, which is the Great Ruhr River Subcatchment. And with this case study here, we have so many issues that are happening in this, and it has gained a national importance because of the services that it provides to the country. First, from the case study here, we have the provision of we have the protected areas. As you can see here, we have the Ruhr National Park, which supports a lot of the ecosystems. Also, from the catchment, we also have the Usangu wetland, which is here. As we all know, the importance of wetlands are the areas which have the fertile lands and with the all time in a year with water availability. So in this catchment, we also have the wetlands here, which are the Usangu wetland. Also, we have the irrigated land. As you can see from the orange here, this is the Usangu catchment, which is basically known for the rice production. Over 30% of the rice that is produced for the country comes from the Usangu catchment. And from the Usangu catchment here, a lot of the irrigation activities are taking place, as we can see here from the map. And also we have the Ihefu swamp, which is just inside the Usangu wasteland, which also provides a lot of the ecological services and provides water to the Usangu wetland as well. Also, this is the upstream, the upstream of the Great Ruhr River. As from the downstream here, we can see that we have the two hydropower plants, which are Mtera Dam together with the Kidatu Dam. All these dams depends water from the Great Ruhr River. And also, this river pours its water into the Rufigi Basin, whereby it's the downstream from the Great Ruhr River. At the downstream here down, we have the other newly hydropower plant, which is currently constructed, which is the Julius Nyerere hydropower plant. As you can see also here, we have the settlements which are clustered to this Usangu catchment area. As I said before, that the Usangu has a fertile land with a lot of agricultural activities that are taking place here, making it a very important place for many people to come for agricultural activities. This is the whole, issues that are happening in the Great Ruhr River subcatchments. Also here, as we can see here, we also have the protected area where the population is even lower. We have the Kisigo, which is the protected area. Here also there are a lot of ecological services that are provided as well. This is the general overview of the case study. Now the problems that are happening in the catchment currently, starting with the biophysical problems, we have extended dry periods that leads to water scarcity. As we can see here from the map, we have the Ruhr National Park, which is just in the upstream of the Usangu catchments. Now, during the low seasons, during the dry during the dry seasons, the river flows become slow, making even water to become as low, even to become low as the ones which are going to the national park. Also, we have deterioration of the river ecosystem leading to the death of hippopotamus. The Great Ruhr River has 480 kilometers long, and with 160 kilometers going into the Ruhr National Park. Now, during the dry seasons, we have been experiencing the deterioration of the ecosystem, especially the death of hippopotamus. As you can see here from the map, there is death of hippopotamus, and other ecosystems are even affected due to low flows in the river. Also, we have environmental degradation, which is highly caused by the deforestation. As you can see here, people are moving to these areas just because of the fertile lands, just because of the irrigation activities that are taking place here. That's because of the agricultural activities. A lot of issues are happening here. So we expect that even the deforestation to be high because people will be clearing the forest for establishment of the settlements. Also, we have been experiencing sedimentation of the river caused by the soil erosion, deforestation, and the like. Those are just the biophysical problems that are noticed in the catchments. We also have the social institutions problems, which we have, especially we have the conflict among the water users. As we can see, the catchment has so many issues. So even the conflicts, we expect the conflict to occur in the catchments. The conflict arises between the irrigators and the hydropower plants. As we can see that the irrigation schemes are just at the upstream and the hydropower plants are on the downstream. So there have been so many conflicts between the hydropower plants here, complaining that the irrigators here at the upstream are obstructing a lot of water, hindering some of the water to go into the power production. Also, there have been conflicts between the small-scale farmers together with the large-scale farmers. Rufigi Basin Water Board has provided, has given the act that the farmers who are supposed, the farmers for irrigations are supposed to pay for the water permits for their use. But then most of the large-scale farmers are complaining that they are the ones who are only responsible to paying for the water permits, while the small-scale farmers are abstracting water illegally from their channels without paying for the fees. So there have been conflicts between the small-scale farmers together with the large-scale farmers. And the small-scale farmers, who are the marginalized group now, are even complaining that with the changing of the climate, the temperature has risen, resulting into low income because there are no produce, and that they don't have money to pay for the system. So there have been conflicts arising between the small-scale farmers together with the large-scale farmers. There are another conflicts that are rising at the catchments now. There are the conflicts between the pastoralists together with the farmers. The pastoralists are complaining that they are not given land for grazing their cattle, while the farmers are complaining that the pastoralists are allowing their cattle to graze into their lands and leading into destruction of their farms. So these conflicts are to be addressed. Also, there have been conflicts between the environmental institutions and other stakeholders, the villagers and the indigenous of the catchments. These environmental institutions include institutions like, we have TANAPA dealing with the national parks. TANAPA has been complaining that as we have seen that we have the Ruaha National Park, TANAPA has been complaining that the villages are even extending their boundaries into the national park while it is a reserve area, and they're trying to reallocate people to move to different areas from the national parks, because the national parks are the protected areas. While the indigenous are complaining that the areas, it is their right and they are not supposed to be reallocated by any institution to another places. So all these conflicts are to be addressed. As we all know that water is a natural resource which everybody is the stakeholder. So with this water, it supports a lot of activities that are taking place. And these activities can be grouped into 3 different systems, which we have the social system, environmental system, and the economic system. Now, once the environmental system is harmed or is disrupted, automatically even the water resources are going to be vulnerable, are going to be as well affected. And as a result, even the economic activities, the ability to support economic activities is going also to be diminished. Also, if this as currently we have moved to the middle income community, and we expect to have a lot of issues like industrialization, a lot of issues are expected to be in our country. So like issues like climate change, issues like land use change are there. So once this economic system is not taken into consideration, even the production of goods and services to the social system, which are the people, is also going to be affected as well. So all these issues requires different disciplines to address all these issues so as to come up with the sustainability of water resource management. And with our project now, the Great Ruaha River Project, the main vision of our project was to unlock the resilience benefits from African water resources. This is the main the main vision of the project. Now, why are we using a transdisciplinary approach? As I've said, that the catchment has gained the national importance, and so we are using the transdisciplinary approach due to its political interest, also involvement of multiple non-research stakeholders, and also we have diverse opinion and expertise, and multidisciplinary. Now the entry points of the transdisciplinary approach in our case study, here at the vision of the project, which was to unlock resilience benefits from African water resources. That is the main vision of our project. Now, this main vision of our project, it is supported by three major objectives. That is hydrological modeling with regards to land use and climate change. We have water resource management, allocation and optimization. We also have participatory governance to water supply resilience and ecosystem protection. Those are the three general objectives that are going to come up with one main project vision. Now, the entry point for this objective is that the hydrological modeling regarding the issue of the land use and climate change is going to come up with the output of the resource availability. That is, we are going to do hydrological modeling and determine the amount of water that is available at the catchment for the water users, so as we can avoid those conflicts. This now is going to help the water resource management, allocation, and optimization. Here we are coming to another discipline for the person who is doing water resource and management and allocation. From this also, we are going to come up with equitable allocation of water on the social perspective, that is social system, governance, and participatory. These are the entry points of the TD approach. Engineering knowledge is being integrated with the social aspects to come up with the main project vision. And as you can see here from water resource management allocation, we are going to evaluate and propose effective basement management system so that we can make sure that in all time in the year that the water balance is not affected in the catchment. Also on these two together, the social system together with the hydrology, we are going to understand the climatic, hydrological, and societal drivers that includes floods, droughts, issues like wars, economic collapse. This is the entry point of our TD research approach. Now, what are the principles that I used, TD research approach principles that I use for our projects? As here we have the purpose, the Great Ruaha River Project vision. We have three things that we have: the integration, we have co-creation, and multidisciplinary. Thanks to Shonan Tali, because he has explained well on these issues, how they link together. As for the integration, we are going to integrate different knowledge inputs to reach new understanding that transcends the boundaries between disciplines and knowledge forms. Thereafter, we are going to, on the co-creation parts, these co-creation parts, we are going to introduce society stakeholders from outside academia in the co-construction of the research agenda and knowledge outcome. All these two together are going to address the complex socio-economic sustainability problems through research, how we are going to address these issues. And also the other principle, we have multidisciplinary. Multidisciplinary because with this multidisciplinary, we are going to draw on research method and bodies of knowledge from more than one discipline. As we have seen prior, that we have the engineering aspect of the hydrological modeling, and also we have the social aspects on the participatory governance to help in the water supply and system and ecosystem protection. That is how we're working, or our case study on the essence of TD approach. Now, what are the challenges of working with TD approach? First, we have on the linkage between stakeholders and their roles. This can be through water, energy, food nexus, because we know they are political and require constant negotiations between and among different sectors, which constitute different views, mandates, and priorities. So it is very difficult to link these stakeholders together. Another challenge is on the tension when working in this TD approach. We have the challenges on science versus management, as explained by Tali prior. We also have scientific management versus community participation. We also have social science versus natural science. And we also have hierarchical governance versus participatory governance, just as how Tali has explained before. And also we have another challenge, which is this major challenge on one of the this is just a specific challenge to one of the discipline, especially on the engineering aspects, especially on the engineering aspect, yes. And it is on the issue of data availability on the catchment. Sorry, I'll take you back to the map. I'm sorry. From this map here, we can see that only on this area here at the upstream here on the Usangu catchment and the area just near it, these are the areas with the gauging stations together with the rainfall stations. But the large portion here, up here, it is the protected area at Kisigo here. We lack data for this place. And this is just because this area is protected. And gauging stations and rainfall stations are not yet installed in this area because this area has some of the wild animals, so it is very difficult to put the station at this area. So data availability for this area, it is very difficult because we need data for this place for hydrological modeling, as we know that these tributaries which are coming from these reserve areas also contribute water to the Great Ruhr River, which is of our interest. Now, if we are using only the stations which are present at the upstream, which here, and the downstream only, without taking into consideration the stations, the data coming from these small tributaries here up at the protected area, we are not going to be precise with our results. So there is a problem with data availability at this area. That is a specific problem for our catchments. And now, what are the anticipated outcome of using a TD approach? First, we have TD approach may help to come up with eco benefits across sectors and society. This can be through benefits between water, energy, and food that can be optimized under different scenarios of the river basin developments. Also, TD approach can inform a collaborative decision towards improving water, energy, food nexus in Tanzania. Also, a coordinated intervention of the benefits water, energy, food nexus across sectors may help to identify the sectorial benefits. These are just the anticipated outcomes that we're going to get when we're going to work on the TD approach. Thank you.